Hey, this is Joe at graybenchelec. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the Klon KTR. The venerable KTR, Klon KTR. Many of you will know, but for anyone who doesn't, this is the remake, the pedal board friendly version of the Klon Centaur. It was designed starting in 2009, right as the production of the Klon Centaur was coming to a close. Bill Finnegan started designing the KTR. He was hoping to have the pedal out by 2010. It took actually until the end of 2011 for units to start shipping for a number of reasons. But it is here, it is out, and there are many thousands of units available. This version appears to be from around 2014 or so. The exterior of the KTR is pretty well known. It does not say Klon KTR anywhere on the pedal. On the back, of course, it does say Klon, Somerville, Massachusetts. On the top, it has a now infamous phrase, kindly remember the ridiculous hype that offends so many is not of my making. On the bottom side here, we have a almost always better / almost always worse switch, which is a buffer switch. So in the left position, it is buffer in circuit, or I should say buffer bypass. So even when the pedal is off, the buffer is still in circuit. When the switch is to the right, it is true bypass. On the top, we have bypass on and off, indicator LED, 5mm red LED, the standard Klon controls of gain, treble, and volume. On the top side here, input and output jacks, 1/4 inch of course, and 9 volts DC jack. One little detail that's hard to see, but the letters K, L, O, N are a slightly darker gray. It's one of a handful of small but clever little design choices with the KTR here. So the Klon Centaur obviously was in that larger cast aluminum enclosure, not particularly pedal board friendly, kind of large, kind of clunky, kind of heavy. KTR is in this 1590 BB enclosure. It has a standard DC jack as opposed to the 1/8 inch jack that was on the Centaurs. It has the buffer switch, of course, and the design inside, as we'll see, is all surface mount. So to that effect, let's go ahead and crack open the pedal. Just pausing here for a second to point out something that bothers me a little bit. And if I know Bill Finnegan, like I think I do, after all that research I did for that diode video, then I think it's going to bother him too. The little ribbon cable being used to connect the daughter board for the foot switch to the PCB is what I would call too short. You can see it's quite taut there. It's so taut, in fact, that it's canting the connector here sideways. It's pulling on the connections, and that is going to be a failure point in the future as this thing bangs around. It's putting a undesigned for stress on the plastic, the metal connections underneath. I might have to give Bill a call and see if maybe he can send me another one of these foot switch units to remedy that. Something tells me the meticulous nature of his design philosophy would not be, or I should say, would be equally as unhappy with that as I am. All right, so we'll get to the KTR PCB in a second. I want to point out some interesting design features of the enclosure here. The enclosure itself is not particularly interesting. It's a Hammond 1590 BB, very standard pedal enclosure these days. Red powder coat, nice, easy, durable coating. Interesting, however, is first off, you'll notice that the holes for the potentiometer shafts are not round. They are a rounded rectangle with rounded or radiused edges. If you just looked at that and didn't think about it much more than that, it would seem maybe to be like imprecise stamping or machining. But in fact, it is a very specific design choice in order to facilitate certain components on the board here. So you'll notice anytime you have orthogonally mounted components. So that is components that are right angles to each other. So pot sticking out this way, right angle to the input jacks and output jacks pointing that way. Also right angle to the buffer switch pointing that way. When you have that combination, it can be very difficult to remove the PCB from an enclosure. You either have to assemble the enclosure with the PCB inside, so put in your pots unsoldered, put the PCB in, soldered up, and then they're mated for until next time you want to desolder stuff, or you come up with some design workaround to get them to fit properly. And that's exactly the purpose of these elongated shaft holes for the pots, is there's just enough clearance where the pot goes through that it can clear the buffer switch. And it is, when I say just enough, I mean really just enough. We're talking thousandths of an inch, less than a millimeter space there to make that fit. And you can see here how the pots can slide or just pivot slightly, just enough to clear that buffer switch, just enough to rock or slide slightly to clear that buffer switch. This is a conscious design choice and a clever solution to getting the PCB assembly here out of the enclosure without having to desolder anything. Another feature I want to point out of the KTR enclosure is the foot switch hole here. It is not just a standard hole, it in fact has a keyway for the foot switch. So most of these foot switches are going to have a keyed slot, and that is a anti-rotation slot, so that when you actually insert the foot switch, it actually cannot rotate because that little nub on the inside of the enclosure prevents rotation. This is one of the reasons that the KTR can get away with having just this sort of vanity nut on the outside, just holding the foot switch in. That's because rotation is handled by the enclosure itself. What this means for the enclosure manufacturing is that you can't just drill the holes. It'll be true for these rectangular holes, for the buffer switch hole. You can't just drill them. You're gonna have to stamp them or you're gonna have to mill them. My guess is these are probably CNC machined. That is going to increase the cost of the enclosure considerably. But it's exactly the sort of idiosyncratic thing Bill Finnegan would do. Input and output jacks, DC jack are just round holes, which could be drilled or maybe just be part of the CNC procedure. Okay, now on to the KTR PCB. Famously or infamously, all surface mount design, including what would be the electrolytic capacitors on the Centaur, are replaced with film caps or MLCC, multi-layer ceramic capacitors for this board. There is a discussion or argument to be had about the sonic implications of doing that. I am not interested in partaking. The fact of the matter is the capacitor has the right value, and so it will do the job that the capacitor is expected to do. We've got here, of course, the two TL072 dual JFET op amps in a surface mount dip package. And then down here at the bottom is, of course, the 7660 voltage regulator. That voltage regulator, same as the Centaur, provides a positive 18 volt supply and a negative 9 volt supply for a total 27 volts of headroom for the output of the Klon Centaur or the Klon KTR. And of course, last but certainly not least are the famous Klon Centaur diodes, or Klon, I guess, KTR diodes. Germanium diodes, unknown manufacturer. Bill allegedly auditioned some 80 different types of germanium diodes when he was building the Klon Centaur. So this would have been 93 or 94. And most of the diodes he tried sounded bad, and this is all according to him. Most of the diodes sounded bad, a few sounded okay, and these ones here sounded the best. So that's what these are, the original Klon Centaur diodes, of course, now also part of the Klon KTR line. At least that was the case until very recently. Bill Finnegan in September of 2021 announced that he is running out or completely out of the original Klon Centaur diodes, these diodes here. And as such, new KTRs will be coming with different diodes. And in order to facilitate that, he had to make modifications to the circuit to get those new diodes sounding like the original Klon Centaur diodes, and just in general, the new KTRs sounding like the old KTRs / Centaurs. He did a live stream where he had 3 pedals, a original Klon Centaur, a old KTR, and a new KTR with the new diodes, and switched between them. I watched that live stream. I couldn't tell a difference between the sound. which either means, one, that he absolutely did exactly what he had to get the new KTR sounding just like the old KTRs with the new diodes, or it means that the diodes just don't matter that much to the sound of the KTR. I will let you decide which of those reasons or which combination you want to go with. On the back side of the PCB, we have a big old ground plane, most likely, some different stickers tested, blah, blah, blah. The Alpha style 9mm potentiometers, PCB mount, of course, and the dual gang gain pot there. On this one, it has a warranty ID and a date of creation DC of 9/23/14. So September 23rd, 2014. PCB mounted input and output jacks are Neutrik. DC jack is PCB mounted as well. E switch or mountain switch for the buffer switch here. The buffer circuit, Bill said, was designed by Paul Cochran of Timmy pedal fame. Another small detail on the PCB that is not immediately noticed are these little plastic standoffs, one here and one here. You can see those here. They don't screw into the enclosure. They're not for mounting the PCB to the enclosure. The only purpose they serve is that when you are installing the connector here for the foot switch, they provide positive pressure back on the PCB. So while you're pushing this down, you're not flexing the PCB in an unhealthy way. It's another one of those little design things that matters for about 2 seconds while this foot switch is being installed, and then not again. Unless, of course, you're like me and you take apart your pedals, in which case it matters every time you pull it in and out. But yeah, so just another little design consideration, which makes sense, but it's extra work, extra time, extra money to get the little standoffs, the drilling of the PCB. But, you know, that's Bill Finnegan for you. He's going to do those extra little idiosyncratic things to make it his and make it to the level that he wants it to be. All right, so we have some Klon KTR diodes, aka the original Klon Centaur diodes. I did a video on these diodes, germanium diodes. If you haven't seen it, it's very long and tedious. But if you are interested in the Klon diodes and the story of the Klon and how those diodes came to be so important or famous or infamous, I recommend checking that out. Check for a link in the description or check in the corner right there for a link. So let's replicate a very famous test that was done on the Klon Centaur diodes. Of course, the Klon Centaur was traced by Freestomp boxes, specifically Solsonic. And during that process, they used their peak DCA 55 to test the Klon Centaur diodes. Is where we got the well-known measured forward voltage value of 0.35 volts for the Klon diodes. This is the DCA 75. For the purposes of this test, it's exactly the same. It's going to test those diodes at the higher 5 milliamps of current. So when I do the test here, it's going to read out as a Zener diode, and that's because the diodes are configured here in a symmetric fashion, and so it's going to read the reverse drop voltage of the opposite diode as a Zener voltage. Just ignore that. We're looking at the forward voltage of the diodes. All right, we are hooked up to run our first test on the first Klon Centaur diode. This is going to give us the forward voltage. Let's see what we get. All right, so this gives us the Zener diode. Of course, like I said, it's just reading the opposite diode as the Zener voltage or the breakdown voltage. But forward voltage here is, whoop, there we go. So this is actually convenient. So the VR is reverse voltage. That's 0.391 volts. So that's going to be the other diode pushing current the other way through that diode. And the forward voltage is 0.386 volts for the diode under test. That brings up an interesting point I would want to make about the Klon Centaur diodes is, which you will now realize, is these are testing at a higher forward voltage than the Klon Centaur diodes. It alludes back to something Bill said or wrote about on the Klon Centaur diodes, which is that he didn't really do testing or matching. He checked the diodes to make sure they weren't broken. Germanium diodes, of course, are made of glass and it can break easily. And then, as long as that wasn't the case, he immediately put them into his little test jig, tested it, and went with there. He may have switched some out if they didn't test right, but there was no matching or testing for forward voltage of the Klon Centaur diodes. Bill didn't do that. He made sure they weren't broken, and then he did a listening test, and that was it. So if you see anyone advertising matched Klon diodes or a specific forward voltage, just know that Although that matching or forward voltage may impart something to the sound of the pedal that you like, there is no lineage back to the original design principles or design criteria from Bill Finnegan. He just didn't do that. He didn't match the diodes. He didn't test them. He just made sure they weren't broken and then did listening tests. Let's run another check. Yep, same thing, 0.385 volts forward voltage for the diode under test, and the opposite diode reading as a reverse voltage, but it's just opposite polarity, so 0.391 forward voltage for the opposite diode. All right, so that is the Klon KTR PCB. Let's go ahead and put the pedal back together. I'm not going to install the little connection here just because I don't want to stress out the pins or the connector any more than has already been done. So we'll leave that disconnected, but otherwise we'll put the pedal back together. All right, so that was the teardown of the Klon KTR. If you have any questions or have a recommendation for a pedal you want to see on a future teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I am Joe from Graybench Electronics. Thank you for watching.